So tomorrow there's 8 problems. They all should be somewhat familiar. I don't think there's any surprises on there. You have to be able to do it in 5 minutes though, that's the thing. Everybody back up 1 foot. Okay, there you go. There's 2 word problems. There's 2 word problems. And shall I give you a big hint?
Yes.
No, I'm not gonna give you.
But you can't mention it.
Yeah, so, well, there's 2 word problems. That's all I can tell you. Okay, so first of all, in Poly 6, number 3. What? Y equal x good. Well, at least you guys are asking this because there's something in there that's important, you know. Okay, should I draw the graph first or should I find where they intersect first? Yeah, find where they intersect first because then you can use those points to help you draw the graph. So what? How do you find where 2 graphs intersect? Like we've been doing the last month. Rhymes with substitution. Substitution. If y equals that, you can substitute that for y. So you get x cubed plus 2x squared equals 4 minus x squared. And what a surprise, it's a polynomial equation. So you make one side 0. And then you factor. Factor by grouping or synthetic division? What are you going to do tomorrow? Yeah, probably synthetic division. So 1. Don't forget to put the 0 or you're just going to like cry. So 1 works. 1, 4, 0. So this stands for x minus 1. And this over here stands for x squared plus 4x plus 4, which is factorable. See how it's all factorable? So x equals 1 or negative 2, which is a double root. And that's something important in the problem, you know, that double root right there. So, you got to give points of intersection now. We just found the x coordinates. How do you find the y coordinates? You plug it back into one of these. Which one looks easier, A or B? I think B, yeah? 4 minus 1, 3. 4 minus 4, 0. So those are my points of intersection. So let's graph that. 1, 3, negative 2, 0. Those are the 2 points of intersection. Now the first graph, okay, well this one's a parabola. Come on. What does that parabola look like? Opening up or down? Are you kidding me? Down. X-intercepts are plus or minus 2. The y-intercept is 4. It opens down, so it looks like this. Ooh. Okay, now what about this graph? Well, you factor out the x squared, and you get x plus 2. So the x-intercepts are 0 and negative 2. And it's a cubic, leading coefficient positive, so it's going to be like this. Now watch. It's going to look like this. Negative 2, go through, come down, bounce off. And it looks like that. How come it went through this one but bounced off that one? Yeah, because this one has a first power, odd, so it's going to go through, and down is squared, so it bounces off. But this one was, remember, negative 2 was a double root. That's why over here, you see this? The graphs bounced off each other. Whereas this one, right here, see how the 2 graphs went through each other? That's because this was a single root, but this one was a double root. See, so you have to show that this graph bounced off that one. You know what I mean? Because I remember this last year, I was checking the homework. This one, people had it out here, but it doesn't. It's actually inside and it bounces off the other graph. That's because of the double root. You guys got that? Oh, I do now. Okay. Number 7. Oh, you guys got the. Number 7. A can is in the shape of a right circular cylinder, top and bottom included. It is to be made from 48 pi square inches of material. So here's the radius and the height. What equation can I write right there, just from reading that first sentence? What is this 48 pi? The surface area. So what is the surface area? Total surface area of this can. Well, you got a circle on the bottom and a circle on the top. What's the area of a circle? Pi r squared, but you got 2 of them. And what's the lateral area of a cylinder? 2 pi r h. That's got to equal 48 pi. You just got 1 point. You guys can write that down, right? And then, what is the radius of the can so that the volume of the can is to be 45 pi cubic inches? Well, how do you find the volume of a can? A cylinder. What's the formula for volume? What? Pi r squared h is equal to, I forget the number already, 45 pi. You write that down, you get another point. You want the other 6 points? Solve it. How do you solve 2 equations, 2 variables? Just like over here. Solve for one letter in one equation and substitute it into the other, right? So what letter is the easiest, what variable is easier to solve for? In which equation? Look at it. What, did you guys do it? Which variable is easy to solve for? Isn't it h in this equation here? Because look, cancel the pi's, divide by r squared. H equals 45 over r squared. Take this and plug it into the other equation, substitution. Okay, so what I would do before I even start, I would divide everything by 2 pi, make the numbers smaller. I don't know, but it seems like some of you like to work with big numbers. So r squared plus rh, but what is h equal to? This is just substitution, people. You learn substitution in Algebra 1, and then, oh, we only got one variable now. That's how you do it. If you do substitution, then you, instead of 2 equations, 2 variables, then you just have 1 equation, 1 variable. R squared plus 45 over r equals 24. How do I get rid of this r in the denominator? You gotta be kidding me. Multiply both sides by r cubed plus 45 equals 24r. What a surprise, it's a cubic equation. That's not a surprise, people. So how do you solve any polynomial equation? Make one side 0, so minus 24r plus 45 equals 0. And tomorrow we're doing synthetic division, yeah? Okay, so factors of 45 over factors of 1. 1 doesn't work, so what should I try next? 2. Try 2. Well, I don't know, you guys, this is dirt. Here's period 3. So what should I try next? 3. Okay, let's try 3. 1, 3, 3, 9, negative 15. Yowza! So r minus 3 is one factor, and then you look at this, that's r squared plus 3r minus 15 equals 0. Once you get it down to a quadratic, you're pretty much done. So your 3 answers are r equal 3, and that's not factorable, so you gotta use quadratic formula. Negative 3 plus or minus the square root of 9 plus 60, 69, all over 2a. Box that. That's the answer. No! Because what's the domain for r in this problem? R is radius, it's the length. Obviously r gotta be greater than 0, but is there any upper limit on what r can be? Like what's the biggest r can be? 10. 100. 1,000. 10,000. Tell me when to stop. 100,000. No, no, no. R can be as big as, okay, tell me why R couldn't be a million. Tell me why R can't be a million. R can be a million, except then the can gonna look like this, right? The radius gonna be really big, and the height gonna be really tiny. It's gonna be like a crepe. You know what I mean? So the domain of this problem is R just has to be greater than 0. So you have to cross out any answer that's not greater than 0, which is this one. There you go. If you don't cross it out, -1. But then tomorrow, what if you gotta cross out 2 of them? That would be -2. In fact, what if tomorrow you gotta cross out all 3 because there's no solution? And then what if you don't have to cross out any at all? Okay, whatever. Okay, moving on. Are you sure that's all the questions from politics? Did I assign number 8?
No.
That's the one with similar triangles. Remember when we did the one with similar triangles? I said that one's going to be on the test. Similar triangles. You already did it for homework. All I can say is now I'm going to have to revise that statement. The similar triangles problem might be on the test. Several days, last week it was guaranteed on the test, but now it's just might be on the test. Similar triangles. Okay, now we're on poly 7. Number 3. What? Come on! This is baby food. Are we doing A or B or A and B? Please. Please help me. We're doing A and B? Okay, I'll tell you right now. You're gonna be lucky if I give you anything this easy on the test. This is just baby food. Wow. Hey, where's the bib? I need a bib. Write a polynomial equation whose roots are 1/2 and 2 minus 3i. Now, if 2 minus 3i is a root, what else is a root? 2 plus 3i. So what is the degree of the polynomial going to be? Now, are you guys using the shortcut method I taught you? The negative b over a, the c over a, and the negative d over a? Or are you just going x minus this, x minus that, and multiply it all up? You can, it works. If you're good at algebra, you could probably, even at doing that long way, probably take only 1-2 minutes. No, for real. You wanna tie me?
No.
The best way is this way, the way I taught you. Remember the way the professionals do it? Assuming a is 1, then you have x cubed minus something x squared plus something x minus something equals 0. How come it goes minus plus minus again, Mr. Park? Because negative b over a is the sum of the roots. C over a, and then negative d over a. I just put the signs in already. Okay, what goes in here? The sum of the roots. What is this plus this plus this? If we cannot add simple numbers, you might as well just do the long way. X minus this times x minus that times x minus that. Look, when you add these two, the i's cancel out. That's 4, people. What's 4 plus a half?
9/2.
Thank you, 9/2. Should I write 4.5 or 4.5 there? No, because you're not using a calculator. If you don't have a calculator, it's better to work with fractions, right? I'm sure your teacher taught you that. Okay, what goes in here? Multiply the roots 2 at a time. Okay, multiply these two. We cannot multiply 1/2 times 2. It rhymes with bun.
1 minus 3.
Okay, but no need write minus 3i over 2, remember? Okay, let's just write it. No, some of you still don't know why. 3i over 2. Now multiply this and that. 1 plus 3i over 2. And that's why you don't need to write it, because they cancel out. All the i's and radicals have to cancel out. How come? Because that's the only way you can get integer coefficients. And then, okay, I guess this is the hard part for you guys. What's this times that? Please get it right. Please. Please. 13. Very good. So that's 15. Put that in there. You guys understand how you get 13? Because tomorrow, you get that number that's minus 3 right there. Each number here can be like 3 points. Up to a total of 8. Finally, what goes in here? Multiply them 3 at a time. So you multiply these two, we already know that's 13. 13 times half? We cannot multiply 13 times a half?
13 halves.
Box that, that's the answer. Don't you dare, you gotta simplify it. And anyway, 9 halves is not an integer. You have to multiply both sides by 2, so you get 2x cubed minus 9x squared plus 30x minus 13 equals 0. Anyway, I don't think there's any problem this easy. Come on, this is like 30 seconds. If you're practiced. If you're not practiced, then who knows how long it takes. And then B part, no! If 2 minus root 3 is a root, what else is a root? 2 plus root 3. And if 2 plus I is a root, 2 minus I is a root. So there's 4 roots, so it's 4th power. Now, do you really want to use this technique? 1 at a time, 2 at a time, 3 at a time, 4 at a time? You know, the negative b over a thing? Or would you rather go x minus this, x minus that, x minus that, x minus that, and multiply it all out? Or would you rather make a quadratic for these two, make a quadratic for those two, and then multiply the two quadratics together? Say yes. Say yes. I think that's the best way. So what? How do you make a quadratic for this? You want to do the negative b over a thing? Or you want to use the math team secret that I taught you last chapter? Pick one, man. Okay, here, this is what I would do. Watch. The sum of the roots is 4. You multiply and you get 1. Finish. Negative b over a is the sum of the roots. What is this plus this? 4. What is that times that? 1. I'm doing the same thing as this, except it's the quadratic, so it's easier. So for these two, you go x squared minus something, x plus something, right? I'm just negative b over a and c over a. The sum of these two is 4. The product is 5. There you go. I got them both already. And then now, multiply them together. Take the first term, distribute it. Take this first term, distribute it here. Maybe I'm going to put parentheses around it. Oh, now I get it. Take the first term, distribute it.
X to the 4.
Okay, but watch. Just watch how the professionals do it. 1, negative 4, 5. Now take this and distribute it. Negative 4, 16, negative 20. Now take this and distribute it. 1, negative 4, 5. Now, my Algebra 1 teacher at King Intermediate School taught me that. What did I just do? Yeah, I took the first term and I distributed it, except I just didn't write the x to the 4th, the x to the 3rd, the x to the 2nd. And then I'm lining up all the like terms. So what's the final answer going to be? 1x to the 4th minus 8x to the 3rd. What is that? Plus 22x squared minus 24x plus 5 equals 0. I don't care what you do, you got to get that. Like I said, if you don't know anything tomorrow, if you don't know anything, just go x minus this, x minus that, x minus that, x minus that, and start multiplying out like a mad dog. You will get this answer, except I don't know how long you're going to take. Okay, that was strange going over that problem, but what do you expect for theory 3? Number 4. This is the problem I told you. Remember I told you this problem's on the test? Last week? It was homecoming, Mr. Park. Okay, anyway, the probability of this problem being on the test is just dropped. It was 1 before, now it's only 0.75. It just went down to 0.7. Okay, find the value. Remember on the homework you have to show that it had a root somewhere between 1 and 2? Remember that problem? Okay, but now, see, it's the same concept, but different now. Find the value of k so that there will be a real root somewhere between 1 and 2. That means the graph is going to cross the x-axis somewhere between 1 and 2. What does the value of k have to be? How did we do this problem? What did we do? What did we do last week? See, this is what you got to think in your head. What did we do on that problem? I don't know, I just copied it off the board. The guilt is sinking in right now. What did we do? We thought of this as a graph, y equal, remember? And then we computed y of 1 and y of 2, right? Okay, what is y of 1? Plug in 1, and what do you get for a y coordinate? What? Plug in 1 for x, what do you get? Plug in 1 for x, and you get k plus 2. Now plug in 2 for x. That's a little harder, Mr. Park. 8 plus 2k plus 1, come on. 8 plus 1, can I use my calculator? 2k plus 9. We cannot even plug in 1 and 2? Oh, I know what I can do toward you. What if I said there's a real root between 3.6 and 3.7? No, don't do that. That's why I'm giving you nice whole numbers, but no, I cannot even plug in 1 and 2. Okay, so what has to happen? In order for the graph to cross, what? Remember? So, look, if this graph is going to be below, the y coordinate down here got to be negative, but then up there it's got to be positive. It's got to go from either negative to positive, right? Or from positive to negative. Yeah, well, Mr. Park, how do you know which one it is? Well, you're going to do both and see which one it works. In order for the graph, you guys understand the concept? In order for the graph to cross the x-axis, it's either got to go from negative to positive or from positive to negative, right? You can't go around the x-axis. Didn't we talk about that? Yeah, I remember that, but okay, so which one you want to try first? This one is negative and that one's positive? Or, you got to pick one and go with it. This one's positive and this one's negative. Because you don't know which one it is. 50-50 chance, pick one. Okay, this one is negative, less than 0 means negative, and that one is positive. Okay, so what's that? Solve this one. We cannot even move the 2 on that side. K is less than negative 2, and, well, come on, we can do this on our head, huh? K is greater than negative 9/2. Does that work? Are there numbers that are less than 2 and greater than negative 9/2? What if I were to ask you this? Think of a number that's less than negative 2 and greater than negative 9/2. Could you do it? Yes, we hit the right one on the first one. So K can be any number that's less than negative 2 but bigger than negative 9/2. That's the answer. We got it on the first one. See, because if you did the other one over here, then this would be greater than, and this one would be less than. So you would get K is greater than negative 2, and K is less than negative 9/2. What numbers are bigger than negative 2, but then smaller than negative 9/2? I'll give you a hint. Negative 9/2 is 4.5. Give me a number bigger than negative 2, but smaller than negative 4.5. Can I use my calculator? No, there are none. There's nothing. That's why that one doesn't work. That's why this is the answer. Oh my goodness, people. Good thing period 3 comes but once a day.
So sad.
Yes! It's like zombies. Except the zombies actually move. Okay, number 5. Okay, I already told you this problem is that there's a problem like this. Of course, it's not going to be this easy. It's going to be kicked up a notch. Okay, here, maybe you know what? Maybe we should put 3 word problems on the test. Why not? Okay, I don't know. The test is almost made already. Find the value of K. In fact, we just did a problem like this yesterday. So the one root is twice another, and all the roots are integers. Okay, I don't know what the 3 roots are, but what should I call the first one? R. Good choice. And then it says, one root is twice another. 2R. And how do I label the third one? You wanna just call it S then? Or just, do you guys have foresight? Okay, let's just call it S then. Nobody has foresight here. Mason, what would you label the third one?
Negative 3 minus 3r.
Yeah, there you go. Okay, never forget the foresight. Okay, now, what did I tell you to do yesterday? Just start writing equations. The sum of the roots, what is this plus this plus this? Gosh. No, yeah, I know, but what is, okay, I'll just write it. The sum of the three roots, it will always be
0.
Who said 0? No, negative b over a. But yesterday, the problem we didn't have this, so that's why negative b over a was 0 yesterday, remember? But now it's not. So what is negative b over a? Negative 3. And that's how we came up with this third root s. See, if you solve for s, you get negative 3 minus 3r. See, foresight. But that's okay, you don't have to do that. You don't have to do it. Just do it. Just do it like this and nobody will get hurt. Okay, now what happens if I multiply the roots 2 at a time? Multiply the first two, go. First two, multiply. 2r squared, now multiply the first and the third. Multiply the second and the third. 2rs, that's equal to c over a. So c over a. Do I have to write the 1? I'm not writing the 1, I refuse. And then if I multiply the roots 3 at a time, 2r squared s, that equals to negative d over a. Zombie class. There you go. You write this down, I give you 3 points. 1, 2, 3. You want the other 5 points? Solve it now. Look, 3 equations, 3 variables. Oh gosh. So what I would do is in the first equation, I already did it already. I don't know why I erased it. S equals negative 3 minus 3r. What do you think I'm going to do with that? Take that and plug it into this equation, and then now you just have one variable. In fact, I would simplify this because isn't 1rs plus 2rs 3rs? Even a zombie would say yes. So we got 2r squared plus 3rs, but what is s equal to? Substituting it in. Equal negative 16. And now we just have one equation, one variable. That's what you want. So you get 2r squared minus 9r minus 9r squared equal negative 16. And it's a quadratic, so I'm going to make one side 0. How come I'm making the left side 0? Because I want the first term positive. Now, I know some of you don't care, and it really doesn't matter. But then, when you start using the quadratic formula, you guys start making some ghastly mistakes. So do I have to use quadratic formula? Or can I factor that? How do I know it's going to factor? Somebody tell me right now.
We can't use it later on.
No, I can make you use quadratic formula. You don't need a calculator to do quadratic formula. Because if you read the problem, it says all the roots are integers. That means you can factor it then, right? I don't know what that means, Mr. Clark. 7r, r. 4 and 4, 2 and 8, 16 and 1, what? 16 and 1. Plus, minus. Oh, when you watch me do it, it's easy, yeah? But then when you gotta do it on your own, then it's hard. That's why you cannot just copy. Yeah, you can copy off the board, but is it gonna help you? No. So r equals either negative 16/7 or 1. How come I cross out this ugly 1? Why am I crossing out that ugly 1?
It's not an integer.
Because it says all the roots are integers. Negative 16/7 is not an integer. What if I didn't say all the roots are integers? Then you don't cross that one out. I'm going to have 2 answers then. Woo! Woo! Okay, so what are we trying to find? Find the value of k. So how do I find the value of k? Right here. Use this equation now. So 2 times r squared times s. What is s equal to? Negative 3 minus 3r. But if r is 1, what is s? Negative 6. That's equal to negative k. Can you figure out what k is? Yes, multiply both sides by negative 1. I will leave that to you. See, so how do you start this kind of problem? You label what your roots are, and then you just go with what you know. The sum of the roots is negative b over a. Multiply them 2 at a time, it's c over a. Multiply them 3 at a time, it's negative d over a. Even if you had a 4th power equation, you do the same thing. Or even a 5th power, or whatever power I give you tomorrow. Label the roots and just go through this. It's very mechanical. It's not difficult. Okay, next. The time is, oh my gosh, even on basic schedule, we're in trouble. Okay, number 7. How many people got number 7? Okay, there's going to be a problem like this on the test tomorrow. In fact, this is number 8. I'll just tell you right now. So those of you who didn't do it, you guys better sit down and grind out this problem. Otherwise, tomorrow it's just going to be bye-bye already. Nay, time for nay. The roots of this equation are a, b, and c. Now, what did I tell you to do? I don't know what the roots are, but if I add them together, you will get negative b over a. If I multiply them 2 at a time, like this, you will get c over a. If I multiply them 3 at a time, you will get negative d over a. And what did I tell you yesterday? If you write that down, you get 1 point. I'm not going to even change this equation. I'll give you the exact same equation. The only thing that I'm going to change is the 1 over a, 1 over b, 1 over c. I'll just change that part. Okay, so I need to write an equation whose roots are 1 over a, 1 over b, 1 over c. So the equation is going to be cubic, okay? So like this. Assuming a is 1. Don't get that a mixed up with this a. That's a different a, yeah? So this is like another problem we did. I give you the 3 roots. You have to write the equation, okay? What goes in here? The sum of the roots. This plus this plus this. 1 over a plus 1 over b plus 1 over c. How do I figure out what that is? We did a problem like this yesterday, people. What did we do? Doesn't that look familiar like we did it yesterday? Yeah, you make a least common denominator. And what goes on the top? BC plus AC plus AB. Hey, you somebody! What is that? It's right there. It's 5 halves. You somebody! That's negative 7 halves. Multiply top and bottom by 2, you get negative 5 sevenths. Okay, what goes in here? You multiply the roots 2 at a time. So multiply the first 2. 1 over AB. Now multiply the first and the third. 1 over AC. And then now multiply the second and the third. 1 over BC. Can I figure out what that is based on these 3 things here? Yes, you make a least common denominator. A, B, C. What goes on the top? C plus B plus A. Hey, you somebody, huh? That's negative 3 halves. You somebody. Negative 7 halves. Multiply top and bottom by 2 and you get 3 sevenths. And then finally, what goes in here? You multiply the 3 roots together. 3 at a time. So this is just 1 over ABC. You somebody! So you get 1 over negative 7 halves, which is negative 2 sevenths. Box set, that's the answer. No integer coefficients. Multiply through by 7. Final answer is 7x cubed plus 5x squared plus 3x plus 2 equals 0. That's your answer. Did anybody notice anything? Math team people, you guys better remember this until you retire from mathematics.
It looks backwards.
I'll tell you what's backwards.
Oh, it looks backwards.
Oh. What do you mean it looks backwards?
It's supposed to-
Look at, compare the original problem with this answer.
Yeah, it looks backwards.
No, the coefficients have been reversed. Backwards is like this. This is backwards. That's backwards. This is not backwards. Like I said, I'll tell you what's backwards. Does anybody notice anything? Yeah, the coefficients have been reversed. Anytime you write a polynomial equations whose roots are the reciprocal of the original roots, you simply reverse the coefficients. Math team people, never forget that. That's a shortcut. So do you think this problem's gonna be on the test, where I ask you for this? No.
No.
Why would, because then you're just gonna regurgitate, right? I'm gonna give you something where you gotta grind it out like this and get the answer. So this is number 8 of tomorrow's test. Okay, and then finally, we got time for, oh gosh. I thought we were gonna finish fast, but then somebody stuck up an extra problem up there. This is a word problem. There's 2 word problems tomorrow, people. Okay, there's a box with a square base and no top. So did you at least draw a picture like that? No more top. And it doesn't matter what letters you use. You can use, I don't know, B and H, whatever, or A and D, it doesn't matter. Okay, it's gonna be made from 64 square feet of material, which means the surface area is gonna be 64. What equation can I write? Well, there's 1 square on the bottom, x squared, and how many sides on the box? Well, 5.
Isn't it a top?
No, it says no top. Wait, let me read. Yeah, no top. You guys gotta read. It says a box with a square base and no top. There's no top. So there's only 1 square on the bottom and 4 rectangles around the side. That's equal to 64. See, like tomorrow, if you did that, you made that mistake. I'm sorry, that's a -8 already. Yeah, but Mr. Park, yeah. But see, then when you solve the problem, you can't solve it because it comes out unsolvable. You know what I'm talking about? So even if you made that mistake, if you solve the problem, then you probably only get -1 or 2, but then you're not going to be able to solve it with that mistake. Just believe me. X represents the length of the side of the base. Oh, no, I even said X. The volume is 30 feet. What equation can I write if the volume is 30 feet? How do you find the volume of a box? Come on. X squared Y equals 30. Okay, 1 point, 2 point. You want the other 6 points to solve those equations. What do? Solve for Y. Probably this equation is easier to solve for Y, right? Solve for Y in this equation, plug it into that one. So doesn't this look like the other word problem we just did? Yeah. It looks eerily familiar. This X cancels into that X. How do I get rid of the X at the bottom? Multiply both sides by X. So you get X cubed plus 120 is equal to 64X. Well, what a surprise. It's a polynomial equation. It's a cubic one. So how do you solve polynomials? Make one side 0. Synthetic division, we're not going to even try factor by grouping, right? So factors of 120 over factors of 1. 1 doesn't work, so try 2. Do you guys notice I always make the second one work? You guys ever notice that? The second one always works. Well, now that I told you that, I'm going to make the third one work. But since I told you that, now it's going to be the fourth one. Anyway, let's try 2. 2, 2, 4, -60. Oh, it worked! The second one worked! So x minus 2, x squared plus 2x minus 60 equals 0. Cannot factor that, so I've got to use quadratic formula, so your answers are going to be 2. Let me see. -1 plus or minus root 61. See, I can do it in my head. You guys got to be able to do it with pencil and paper. This thing over here. A lot of you, you're just copying it down now, or when you get here, you look at the answer on the bottom. I don't copy it. And then what happens when you got to do it for real on the test? Pain. That's what's going to happen. Box that, that's the answer. No. Why? Because when I look at the bottom, don't have this -1, Mr. Park. So I got to cross it out because it's not there on the bottom. Because x got to be positive. Oh man, we just barely finished. Now normally I don't say good luck on a test because luck has really nothing to do with it, but I think for you guys, maybe it's faster, so good luck. People, you have to sit down and grind it out. That's how math works. And did Komea come to school today? Did anybody see Komea? Well, if anybody sees him, tell him he's in big trouble. Wow, so much